Laundry detergent, or washing powder, is a type of detergent that is added for cleaning laundry. In common usage, detergent refers to mixtures of chemical compounds including alkylbenzenesulfonates, which are similar to soap but are less affected by hard water. In most household contexts, the term detergent refers to laundry detergent versus hand soap or other types of cleaning agents. Whilst detergent is still sold in powdered form, liquid detergents have been taking major market shares in many countries since their introduction in the 1960s. History: from ancient times, chemical additives were recognized for their ability to facilitate the mechanical washing with water. The Italians used a mix of sulfur and water with charcoal to clean cloth. Egyptians added ashes and silicates to soften water. Soaps were the first detergents. The detergent effects of certain synthetic surfactants were noted in Germany in 1917, in response to shortages of soap during World War I. In the 1930s, commercially viable routes to fatty alcohols were developed, and these new materials were converted to their sulfate esters, key ingredients in the commercially important German brand FEWA, produced by BASF, and Dreft, the U.S. brand produced by Procter & Gamble. Such detergents were mainly used in industry until after World War II. By then, new developments and the later conversion of aviation fuel plants to produce tetrapropylene, used in household detergents, caused a fast growth of domestic use in the late 1940s. The use of enzymes for laundry was introduced in the early part of the 1900s by Otto Röhm. Only in the latter part of the century with the availability of thermally robust bacterial enzymes did this technology become mainstream. At the present time, soap has largely been displaced as the main cleaning agent in developed countries. Soap is, by weight, relatively ineffective, and it is highly sensitive to deactivation by hard water. By the 1950s, soap had almost been completely replaced by branched alkylbenzenesulfonates, but these detergents were found to be poorly biodegradable. Linear alkylbenzenesulfonates, however, proved to be both highly effective in cleaning and more biodegradable than the branched relatives. Labs remain the main detergents used domestically. Other detergents that have been developed include the linear alkylsulfonates and olefine sulfonates, which also resist deactivation by hard water. Both remain specialty products. For example, only an estimated 60 million kilograms of the sodium alkylsulfonates are produced annually. During the early development of non-soap surfactants as commercial cleaning products, the term syndet, short for synthetic detergent, was promoted to indicate the distinction from so-called natural soaps. Chemistry of detergents. Many kinds of molecules and ions can serve as high-efficiency surfactants. They are often classified according to the charge of the molecule or ion, the three main classes being anionic, neutral, and cationic detergents. Anionic detergents are most commonly encountered for domestic laundry detergents. Detergents are ions or molecules that contain both polar and nonpolar components. The polar component allows the detergent to dissolve in the water, whereas the nonpolar portion solubilizes greasy materials that are the usual target of the cleaning process. An estimated 6 billion kilograms of detergents are produced annually for domestic markets. Components: modern detergent formulations the entire product versus just the surfactant contain several components. Three main ingredients are builders, the alkylbenzenesulfonate surfactant, and bleaches. Builders are water softeners. These chemical compounds are agents that remove calcium ions by complexation or precipitation. Typical builders are sodium carbonate, complexation agents, soap, and xylites. They function by sequestering or precipitating the problematic ions. One of the most common builders is sodium triphosphate, which is used on very large scale for this application. Bleach. The main targets of bleaches are of vegetable origin and include chlorophyll, anthocyanin dyes, tannins, humic acids, and carotenoid pigments. Most bleaches in laundry detergents are oxidizers, for example, sodium perborate or sodium hypochlorite. In addition, other agents are added as bleach activators, to enhance the effectiveness of the bleaching agent. A popular one is tetrastyrethylanideamine. Enzymes. The amounts of enzyme can be up to about 2% by weight of the product. These agents are required to degrade recalcitrant stains composed of proteins, fats, or carbohydrates. Each type of stain requires a different type of enzyme, that is, protease for proteins, lipases for greases, and amylases for carbohydrates. Other ingredients. Many other ingredients are added depending on the specific application. Such additives modify the foaming properties of the product by either stabilizing or counteracting foam. Other ingredients increase or decrease the viscosity of the solution, or solubilize other ingredients. Corrosion inhibitors counteract damage to washing equipment. Dye transfer inhibitors prevent dyes from one article from coloring other items. Anti-redeposition agents are used to prevent fine soil particles from reattaching to the product being cleaned. Carboxymethylcellulose is used for this purpose. A number of ingredients affect aesthetic properties of the item to be cleaned or the detergent itself before or during use. These agents include optical brighteners, fabric softeners, and colorants. A variety of perfumes are also components of modern detergents, provided that they are compatible with the other components and do not affect the color of the cleaned item. The perfumes are typically a mixture of many compounds, a popular component being cyclohexyl salicylate, which is related to oil of wintergreen. Environmental concerns. Early in the introduction of sulfonate-based detergents, concerns were voiced over the low rates of biodegradation of the branched alkylbenzenesulfonates. This problem was addressed by the introduction of linear alkylbenzenesulfonates. A more profound problem arises from the heavy use of sodium triphosphate, which can comprise up to 50% by weight of detergents. The discharge of soluble phosphates into natural waters has led to problems with eutrophication, or the growth of living things, of lakes and streams, often where it is not desirable. The replacement of sodium triphosphate by zeolites offers some relief to this problem. With respect to the phosphate additives, between 1940 and 1970 the amount of phosphates in city wastewater increased from 20,000 to 150,000 tons per year. With an increase in phosphates, especially in the absence of species feeding upon algae, algal blooms grow splendidly on the excess phosphorus and can produce toxins, killing fish, dolphins and plants. They can also indirectly cause oxygen depletion at greater depths, through microbial breakdown of dead algal cells. In 2004, the European Union introduced regulations to require biodegradability in all detergents, and intends to ban phosphates in domestic products from 2013. Australia began phasing out the use of phosphates in its detergents in 2011, with an all-out ban expected to take effect in 2014. Italy started phasing out phosphates in the 1980s. Pursuant to findings published in 2006 by the Schenker College of Engineering and Design indicating that liquid detergents are much more environment-friendly than powdered detergents, Israel's Ministry of the Environment began recommending that consumers prefer liquid detergent over powdered ones for laundry which is not heavily stained. References. External links, Derbyshire, David. Don't bother with pre-wash. Mail Online. Retrieved September 30, 2010. About.com, Housewares Appliances, What is HE laundry detergent and when are high-efficiency detergents used by Mariette Mifflin, Campbell Tips for detergents chemistry, surfactants, and history related to laundry washing, destaining methods and soil.